Preparation of aldehydes and the ketones. Now we will discuss what are the different methods of preparing aldehydes and the ketones. We can get aldehydes and the ketones by the oxidation of the alcohols. Alcohols, we know the general formula is ROH, and if you can oxidize the alcohols, you will get aldehydes and you will get ketones, depends what type of alcohol it is. If you have a 1 degree alcohol, like you got the CH2OH, if you oxidize it here by using an oxidizing agent, this carbon CH2OH converts into the C double bond OH, means you get an aldehyde. So from a primary alcohol, from a 1 degree alcohol, from a primary alcohol, you get an aldehyde. Alright, this is an aldehyde. And if you have a secondary alcohol, like you got RCH, R and OH. Now if you oxidize this molecule here, now this gets converted into Cu and with 2 R groups, that means you get a ketone. So you get a ketone by the oxidation of secondary alcohols. From primary alcohols you get aldehydes, from secondary alcohols you get ketones. The oxidizing agents normally we use for this oxidation process are mild oxidizing agents like PCC, pyridinium chlorochromate, or PDC, pyridinium dichlorochromate, Fenton's reagent, which is ferrous sulfate and the hydrogen peroxide, the Collins reagent also. So these are some mild oxidizing agents that we can use for the oxidation of alcohols and alcohols into aldehydes and ketones. Here's an example. This is an ethanol. If you use the PCC, pyridinium chlorochromate, this particular carbon gets converted into COH because this is a 1 degree alcohol. So from an CH3CH2OH you get the CH3COH. Now this is our secondary. From this one you get acetone. Right? From secondary you get an acetone here. Here again we can use the mild oxidizing agents. We can convert this CH2OH into CHO. And one of the important property of these mild oxidizing agents like PCC or the PDC or the Collins reagent is that they do not act on the double bonds, right? They don't act on the double bonds, so you can keep these double bonds as such. There will be no effect of these mild oxidizing agents on the double bond. However, if you use a strong oxidizing agent, then you will get altogether different products. So normally, if you want to oxidize alcohols into aldehydes or ketones, the best choice is using the mild oxidizing agents. We know there are some strong oxidizing agents also, like you can say the KMNO4, potassium dichromate, right? But they have a little bit limitation. That the limitation is because if you use alcohol here and if you oxidize it with KMNO4 or if you use the potassium dichromate, you get an aldehyde first, but the aldehyde will be further oxidized, right? It will be further oxidized into carboxylic acids. So that's why the best choice is not using a strong oxidizing agent. The best choice here in the synthesis of aldehydes and the ketones is we use mild oxidizing agents. We can get aldehydes and the ketones by the dehydrogenation of alcohols as well. Dehydrogenation means you are removing the hydrogen molecule from the alcohol, and if you take an alcohol and you heat it strongly in presence of a copper, which is here a catalyst, and heat it strongly, then what will happen? The hydrogen from this OH and one more hydrogen from here, it will be lost and you get a ketone plus what you get? You get a hydrogen molecule, right? So this is a dehydrogenation of alcohols. From the dehydrogenation of alcohols again you can get aldehydes and the ketones, and this will be called as a catalytic dehydrogenation, right? It's also called as a catalytic dehydrogenation because we use here the catalyst, the copper, and you strongly heat it, and loss of hydrogen is there, and you get aldehyde or a ketone, depends what type of alcohol it is. Since this is a secondary alcohol, so you get a ketone. If you have a primary alcohol, then what you will get? You will get a 1 degree alcohol. You will get aldehyde there, right, from the 1 degree alcohol. Let's take here an example. If you have the CH3 CH2OH and you heat it strongly in presence of a copper, alright, then what you will get, again the hydrogen gas will be lost, H from here, 1 from H from here, and then you get a carbon oxygen double bond, so you get CH3 C double bond OH plus H2. So dehydrogenation, you get an aldehyde from a primary alcohol. From secondary alcohols you get ketones.